Thanks.
Thanks, Aaron. All right. Sagi, so are we doing Friday afternoon or Saturday when we talk about DevCon 2027? Because you've now had me follow first a professional communicator. That was great. He had a JR, whatever his name was, story. And now I have to follow the illustrious Dan Ames. I don't even have a BYU hat, although I kind of do wish I had one. All kidding aside, one of the nicest things about Cairo is appreciating what you missed out on. And I missed out on studying at both BYU and Utah State when my 10-year time here at Utah came to an end in 2010. So let's get into it. I'm back. I apologize. I think Sagi said something about taking a nap. Please feel free to use this time to do just that. When we talk about Cairo, we often describe it as a research consortium. And of course, it is just that. But it's a remarkable collection of universities, scientists, engineers, students, developers, and operational practitioners who are all working together on advancing hydrology. This morning, I want to postulate that there's something more to this. There's a broader meaning. Cairo is increasingly becoming a part of a much larger national water prediction enterprise. We're not just an academic consortium. We're not just a NOAA initiative. We are part of an interconnected federal water community. And we'll hear more of that this day from our colleagues from NOS, from the USGS. We heard from our colleagues at Reclamation yesterday. And of course, we'll hear from NIDIS as well, part of the NOAA family. No one organization fully owns this problem. These challenges that we see, I enumerated them yesterday, but flood operations, reservoir management, water supply, et cetera, they are all part of an institutional challenge to this nation. So today I'm going to talk about three partnerships that I think are key and illustrate the power that Cairo has to bring advanced technologies, the best in breed in science, the best in breed in creativity and curiosity, because those are the foundations of solutions to our nation's challenges. So 3 agencies, 3 programmatic areas, and my notes are upside down. That's always wonderful. I would argue that these 3 examples are how federal community can work best in becoming an extension of the Cairo community in and of itself. First partnership is with the Army Corps of Engineers. We'll talk about FIRO, or FIRO, depending upon how you say it. The second is the emerging work that we're doing with the Bureau of Reclamation around snow hydrology and water resources prediction in the West. And the third is a foundational partnership that we have with the U.S. Geological Survey, both around hydrography, the critical observations that power the predictive capabilities that NOAA provides, and the underlying hydrofabric that underpins much of the next-gen framework and the hydroinformatics that we all endeavor to focus on as part of our Cairo activities. What ties all 3 of these together is this. Research is no longer enough in and of itself. Operations are no longer enough by themselves. And infrastructure is no longer enough on its own. The future is integration. Integration across all 3 of these pillars: research, operations, infrastructure, science, community. Let's dive into FIRO. The Army Corps of Engineers Forecast Informed Reservoir Operations is not something new to the concept that much of the Weather Service has supported in the past. It is transformational in this, though. It is the application of actuarial predictive hydrology to risk-based, consequential-based reservoir management. We're moving away from deterministic forecasting towards prediction that is probabilistic in nature. And this may sound subtle, but it's actually a very profound shift. Historically, hydrology has largely organized itself around these deterministic forecasts. And we talked about the challenges that deterministic forecasts and stage discharge relationships presented yesterday. I won't enumerate that. What makes FIRO important is it's not simply that it uses forecasts for reservoir operations. It's that reservoir operators have always used forecasts for operations, as John Lotak would say. What makes FIRO important is that it is an operational ensemble reasoning. The question becomes not just what is a forecast, but instead, what is the probability of exceeding the consequential threshold? And again, I'm harping back on things I spoke about yesterday because this is a fundamental shift that I would like us to focus on for the next 5 years of Cairo. How do we transition from the deterministic and or informed-based communications to actuarial risk, consequential impacts? This aligns very much with what the sophisticated water management community needs today, and is where OWP's work around HEFS is so important. HEFS provides the operational ensemble forecasting and the capability to support these decisions. It is also where Cairo enters into the picture. The Cairo FIRO, not pun not intended or rhyme not intended, is not just theoretical in its application. It's building operational capability. It is supporting hydrologic ensembles, forecasting through the forecast testbeds at CW3E, or colleagues at Scripps. It is helping to develop end-to-end forecast-informed reservoir operation frameworks and supporting verification protocols like TIER, which we'll hear about later today. It's helping establish baseline stream flow forecasting capabilities. And more importantly, what CW3E is doing is embedding forecasters and operational scientists at the river forecast centers. It is an actual extension of Cairo into the community, into the ecosystem of OWP. For those of you that do not know, 2026, January 1, which we like to call Monday, marks the beginning of the integration of the 13 river forecast centers with OWP, one financial management center for all of water within the National Weather Service. That's a big deal. I also want to emphasize that NOAA is not owning FIRO. This is a shared partnership. It's not that FIRO is a NOAA enterprise. It is an ecosystem that is formed by partnerships with the Corps of Engineers, the U.S. Geological Survey, our partners in the various states and locations. So FIRO succeeds because it is collaborative. The Corps brings the operational reservoir expertise, CW3E brings its expertise in atmospheric rivers and science, and the RFCs bring their expertise in operational hydrology. Again, a shared collaborative community ecosystem. And of course, NOAA brings the research that accelerates the capabilities in this venture. No single organization could have made this happen. And that's the point I want to make as we talk about FIRO, that this is the realization of what we see here today, this cohort, this august community of cooperative researchers, practitioners, and operators that is establishing transformational change across reservoir management in the West. The second thing I want to talk about is a concept that Ken Nowak at the Reclamation and I began discussing just a short time ago, facilitated in no small part by RTI. So shout out to our colleagues at Research Triangle Institute. Here's what we're thinking about a transformational change in snow hydrology in the West. Historically, Western water management is built around infrastructure, dams, reservoirs, canals, diversion, storage systems. But increasingly, the limiting factor is not simply the infrastructure itself, it's in the prediction of the water coming into that infrastructure. How actuarially can we characterize snowpack? How well can we establish spring runoff timing? How early can we identify drought development? You saw yesterday in James's presentation that in January of this year, we were forecasting 50% of average inflow to Lake Powell. We're now looking at somewhere around 13%, a critical departure from that forecast in January. These are becoming the defining operational requirements, and they're incredibly difficult scientific problems that I would postulate we cannot challenge without the existence of a group like Cairo. Snow hydrology remains one of the greatest challenges in operational prediction. Mountain terrain is observationally sparse. Snow processes remain highly variable. The snow model that we use operationally is a temperature index model developed by Eric Anderson in the 1970s, Snow 17 for those of you familiar with it. Vegetation interactions, of course, matter. Energy balance matters, as we've seen with Utah Energy Balance Model as a precursor to the modernization of snow hydrology models that we need to deploy operationally. Remote sensing matters, assimilation matters, and timing errors in snowmelt forecasting can propagate throughout the entire reservoir management system. So I think that the planned collaboration between OWP and Reclamation in 2027 is potentially very important. The intent is not to simply launch another research initiative, but the intent is to organize research investments around operational forecasting needs. And one concept that we've been discussing is the development of a structured technical questionnaire and assessments across agencies and research communities, not as a bureaucracy, but as a mechanism to ask very practical questions. What observations matter the most? Which snow variables limit forecast skill? What basins are most sensitive to snow water equivalency uncertainty? What assimilation methods are mature enough for operational evolution? What are and where are the largest gaps between research capabilities and operational implementations? And most importantly, how should we develop priorities be governed by joint cross-jurisdictional, cross-agency prioritization? One of the realities that we're encountering is that no single agency owns the entire snow prediction problem. It's a partnership between the operators, the observers, the forecasters, including NOAA and the USGA NRCS. Increasingly, these efforts need a common architecture. One of the reasons in the discussions around a multi-agency snow modeling and data assimilation platform is to facilitate just that. Potentially building upon SNODAS, we could look at a federated approach to snow assimilation, snow data, investments in snow science. I have not been advancing my slides, have I? There we go. Close enough. So I think this is where Cairo has a unique opportunity, right? We've been investing 5 years of snow science research. I don't know the number of dollars, but there have been significant investments in Ryan Johnson's work, in iSnowball by McKinsey, in various data simulation applications. They've all come to a technology readiness level that I think is ripe for harvesting and operationalization. So this work really matters because water forecasting is now becoming the analog for investments in infrastructure. In the 21st century, predictive capabilities is becoming part of the national infrastructure, not just an augmentation and operationalization of that. Forecasting systems influence reservoir release, agricultural planning, hydrologic operations, insurance decisions, drought resiliency, energy management. And that is a profound implication that we now think about Cairo's role moving forward. I know we look forward to discussing more of this at the science meeting, but in 2027, and I'm alluding to the fact that there will be a 2027. I don't want to steal Steve's thunder, but there will be a 2027, and one of the thematic areas will be looking at the transition of snow hydrology into the operational roles of both the National Weather Service, NOAA, and our partners across the federal sector. The last relationship that I want to highlight is with the U.S. Geological Survey. In many ways, this is one of the most foundational relationships we have across the federal landscape. Modern hydrology prediction ultimately depends upon two things: observations and representation of the landscape. And without those two elements, nothing else works. Not a model, no assimilation frameworks, no flood inundation services, no forecasting of ensembles. So this is why programs like 3DEP and 3D hydrography are so consequential. At first glance, hydrography and elevation may not sound exciting, but this is absolutely foundational to the national scale water predictions. In fact, it had not been for the evolution of the NHD+, we would not have chosen that as a basis for the first hydrofabric back in 2013. The quality of the hydrofabric determines the quality of the model's behavior. Flow paths, catchment, drainage connectivity, channel representation, terrain structure, hydrologic conditioning. There are no secondary details. They're all physical structures that underpin the predictive system itself. And I think Cairo and OWP, the concept of the hydrofabric is important because precisely it recognizes this reality, that space and time matter. The hydrofabric is a common framework that allows model, forcings, observations, inundation mapping, calibration systems, and forecasting services to connect cohesively. 3DEP has been a huge lift for the U.S. Geological Survey, and it has been an underpinning of the 3D HP program. Without these investments, which we need to advocate for better as a community, we would not have the capabilities that we need to bring to bear today for all manner of hydrologic predictions. The last piece I'll speak to is NGWAS, the Next Generation Water Observation System. Augmentation of our observing platforms is critical to not only forecasting the variables that we hold near and dear to our hearts, like stream flow, but better understanding of stream flow temperature, turbidity, water quality information. This points towards another major transformation in hydrology. Historically, hydrologic forecasts have often been constrained by sparse observations. But today we enter a world where observations are becoming more diverse, more continuous, and more geospatially extensive, and increasingly assimilated in near real time. SED, water quality, soil moisture, groundwater, distributed stream observations, and remote sensing, these all enable the underpinnings of enhanced Cairo-supported, Cairo-enabled water predictive capability. So I don't want you to think of Cairo just as simply becoming a large research consortium. I want to think of Cairo as the future role. Potentially, it's much more important than that. And Cairo can become the part of the connective architecture of the national water enterprise, a place where agencies collaborate, where research matures operationally, where governance discussions occur, where modeling frameworks evolve, and where operational practitioners and researchers learn from each other on a continuous basis. The drivers are there. Flood risk is increasing, water variability is increasing, operational complexity is increasing. The needs for our capabilities today are greater than they ever have been in the past. So we are observationally rich, we are geospatially informed, and with this partnership across the federal enterprise, I'd postulate once again that Cairo is not just a cooperative institute for research operations in hydrology, it is a community for research operations in hydrology, and that's inclusive of the federal partners seen here today with U.S. Geological Survey, Reclamation, Corps, and many, many others. So I'll stop there. We have a long day to get through. Looking forward to the discussions, and I can take a few questions. I hope bureaucracy is not something that you want to talk about. I'd rather talk about science. So I'll stand here for 30 seconds, or is the David Valley rule, the David Valley 7-second rule, and then I'll get off the stage. Thank you.